Number 34. Part A asks you to just figure out which of these points lie on that curve. So just plug in an x of 2 and a y of 3 and see if it equals 1. And this one has 3 points that work. This one works, this one works, and this one works. And this one wasn't included on the answer sheet. That was just a mistake. So this is the only one that doesn't work. Part B says to write the equation of the tangent at each of those points. So that's like doing 3 problems. So first we need to find the slope, and that means find the derivative. And because there are x's and y's in here, you're going to use implicit differentiation. Remember, that means when you do the derivative of an x, you do the derivative like normal, but since we're doing the derivative with respect to x, if I differentiate a y, I have to tack on a chain rule, an extra dx, a dy dx. Okay, so the derivative of this, the derivative of x squared is 2x. The derivative of xy requires a product rule. And I always put this sign, it's a positive so it doesn't really matter, but I put this sign with the x. So I have an x and a y, product rule. The derivative of x is 1. The derivative of y with respect to x is 1 dy dx. Okay, product rule crisscross, and you're going to get x dy dx plus y. Then the derivative of the negative y squared is negative 2y dy dx. And don't forget the derivative of the right side, the derivative of a 1 is 0. Okay, so this is what we have to work with. We want to get the dy dx by itself. So leave anything that has dy dx on the left side, and the non-dy dx terms are going to go to the other side. So I have x dy dx minus 2y dy dx equals, move the other stuff over. I'll have a negative 2x and a negative y. Factor out the dy dx, and you can do a lot of this without showing the steps like I am. And then divide by x minus 2y to get the dy dx by itself. Now, if it were just stopping here, there's more than one way to write this derivative. I could simplify maybe, not really, not too much. I could multiply everything by negative 1 over negative 1 and look for the answer more than one way. But no point in even thinking about simplifying, because what I'm now going to be doing with this is plugging in these x and y values. So at 2, 3, my first point, dy dx at 2, 3 means I'm just going to plug in an x of 2 and a y of 3. So it'll be negative 4 minus 3, 2 minus 6. So what is that? Negative 7 over negative 4, or 7/4. Then, using that point and that slope, write the equation of the tangent. So y minus 3 equals 7/4 times x minus 2. Okay? But unfortunately, you're not done. That's just the tangent for this point. You now have to do this process again for each of the other 2 points. Okay, so I'll do one more. At 1, 1, dy dx, evaluated at 1, 1, would be, plug in 1 for the x and 1 for the y, and you'd get negative 2 minus 1 and 1 minus 2. So that's negative 3 over negative 1, which is 3. So my equation for this point would be y minus 1 equals 3 times x minus 1. And do that one more time for the point 1, 0, but I'm not going to do it. You go ahead.